Flack math! Give me some math and I'll give you some flack. Flack math!
Number 11, solve this sucker. 30 over x squared minus 9 equals 2 over x minus 3. All right, I'm going to get the solutions up here just in case. Just in case.
I got a bunch out here. I got you.
Okay, ready?
Yes.
So, what's the first thought that comes to your mind when you see this? Not, oh, poop, but like, what do you think you're going to have to do?
So get the same denominator.
Yeah, so I get the same denominator, which is our f-bomb, and we can f-bomb it. So this is an x plus 3, x minus 3, right? If we factor it.
Yeah.
So basically, this guy just needs an x plus 3 over here, right?
Yeah.
That needs an x plus 3. Okay. This is one way to do it. This is what I would prefer, to do it this way, but you don't have to. Now that we have the same denominator, what can we do next?
Will it simplify the Yeah. No.
Well, if I simplify, then
Well,
I
now you need
wouldn't have.
distribute on the top. Distribute on the top.
Yeah, you could 2x plus 6. Yeah, but here's the deal, guys. When you have the same denominator on both sides of an equation, you can ignore the denominator. Okay?
Perfect.
Because our f-bomb is just this. If I multiply both sides by this denominator, it's going to cancel it out. Okay? So here's my equation. 30 equals 2x plus 6. X equals 12. That's it. That's pretty simple, right? So if you find a common denominator, good. So finding a common denominator means you're probably going to have to change the numerators at all and stuff. But once you find a common denominator for both sides of an equation, you can ignore the equation, or ignore the denominator, not the equation. Okay? So because theoretically what you're doing is you're multiplying both sides by the denominator, so it cancels the denominator. So x equals 12. Does that feel okay?
Yeah.
All right. So find a common denominator, then ignore it. Number 12, write a piecewise function for function rule for this graph. Okay, so it kind of sets it up for you. F of x equals. So we got a caller. Let's go to our caller, Mr. Donut. All right, we're on number 12. Drew. Number 11, find a common denominator and then ignore the denominator because really it just cancels out. So number 12, write a piecewise function. So it looks like, let's start on the left side here. What's the value of that? What's the y value of that? That looks like 6. So basically, it equals 6 if what's happening? It equals 6 if it's in between what and what? You see it?
What?
So it's 6 when x is between -7 and -4, right? You see that? Okay. So, but it could be -7. But it's not -4. So -7 less than or equal to x is less than -4. So at 6, the value 6 in between -7 and -4, including -7, but not including -4. You see why it's including -7 and not including -4? Okay, filled circle, open circle. All right, and then it goes down to, let's see, what is that, -3? If x is in between -4 and inclusive, so -4 inclusive and +3 exclusive, right? So it's in between -4 and 3, including -4, but not including 3. Okay, last one, it goes up to 3 if x is in between -3 or +3 inclusive and +8 non or exclusive. Okay, does that feel all right?
Yes.
So piecewise functions are real easy. It's hardly math, but there's yeah, it's easy. Just describe it. What's it doing? Okay, moving on. 13 through 20. The bases of an arch are 60 feet apart. Okay, 60 feet apart. The arch has a height of 40 feet. Write a quadratic function to approximate.
Attendance, please. Culinary, Mrs. Madison.
Write a function to approximate the arch. Okay, so it looks like an upside down parabola, right? So the arch has a height of 40 feet. So this is 40 feet. And it is 60 feet apart. So this is 60 feet apart. Okay, so if we put this like as a vertex in the middle, then we would have, it's an upside down, so f of x equals negative something. So if you guys aren't going to listen, that's fine, but just don't be distracting to people who are listening. Okay, so this looks like it's a negative. And if I drew a graph here and call that and put that in the vertex, then I would have, 60 feet apart. So it looks like it's going there, blah, blah. So maybe it is a little different. 60 feet apart. It's a height of 30, 40. Estimate the arch. Did we do this? So we're going to use vertex form. So here's the vertex form. So negative. If we put it in the middle, we're not going to put it in the middle. So it's basically x minus 30 squared plus 40. Okay, so halfway between the 60 feet apart would be 30. So the vertex is at 30, 40. It's upside down. So you can write that. And they have something different. What is that all about? I'm not sure why they have that. Let's just have a look. Okay, yeah. this is where the application questions might be useful. Maybe I'll do those next year. Base of an arch is 70 feet apart. The arch has a height of 40 feet. Write a quadratic function. So it's the exact same thing on page 588. So it's parabolic. Okay, so to set the x-intercepts, 0, 0, so 35. Yep, they did the same thing. The vertex is right. So use the vertex, form a quadratic equation, blah, blah, blah. Okay, and so the only other thing you need is this component right here. So you need this A. You need to figure out if it stretches the arch or not. So if I were to do this, let's solve for A. So first of all, let's simplify this. So this is x squared minus 60x plus 900 plus 40. So this is negative A times all that. Okay. So then we're going to substitute in our vertex. We're going to put 40 into here. So negative A times, not 40, but 30. So 30 squared minus 60 times 30 plus 900 plus 40. Okay. All right. So we'll get negative A times 900 minus 1800 plus 900. So that ends up being 0. Right? Did I do that right? And then you have 40 over here. So actually these 40s cancel. Well, we knew that. Oh. Okay, so we're just doing this y-intercept here. So if we put 0 on both sides, that's a better way to do it. 0, 0, because our y-intercept is 0. So 0 equals negative A times 900 plus 40. So get rid of 40 equals negative A times 900. Divide by 900. So A equals positive 4900ths or 4/90ths or 2/45ths. Right? No. Yeah. So A equals that. So it's a negative A. So basically 2/45ths. So then your final equation is going to be, or basically plug in 2/45ths in for A, and you end up with f of x equals this crazy decimal number. Where is it? Negative 0.044 x squared plus 2.67x. Okay. So once you find your vertex, then you have your equation in vertex form. All right. Over 30, up 40. Then solve for A by calculating the y-axis intercept, or the 0 functions is going to be at 0, 0, because that's how we set up the graph. And then solve for A. Once you have your A, plug it back into your vertex form to get a nice equation like that. Or you can just leave it in vertex form. That's fine too. All right, that is number 13. Moving on to 14. Why erase that? Number 14, classify by degree and number of terms. So negative 5x to the 5th plus 3x squared minus 8. Degree is that biggest exponent. Degree is 5. Okay, number of terms, this is a trinomial. So this is a trinomial because it's 3 terms. Now it's missing some degrees like the x cubed and the x to the 4th and the x term, but this is a trinomial. And since it has a degree of 5, we're going to say quintic. Ew, ugly. Quintic trinomial. Now you don't have to say quintic. You don't have to remember that word. If you just say degree of 5, that's what a quintic polynomial is. It has a degree of 5. Just like a quadratic polynomial has a degree of 2. A cubic polynomial has a degree of 3. What's 4? What's the degree of 4? Quartic. That's right. So quintic and quartic are the hard ones to remember, but we won't go above that. Okay? All right. Next, number 15. We're going to solve by finding the sign of the numerator and denominator of the rational expressions. Okay, so first we have to figure out our asymptotes. Okay, so it's already in this form. So we have to figure out what is going to break this. First of all, what x is going to break this? Not negative 3, right? It's negative 3, so that's negative 3. And remember when we went over this, what was the rule? Like if they have the same degree, there's something happens. If the degree of the top is bigger than the degree of the bottom, then something happens. And then if the degree of the top is smaller than the degree of the bottom, then something happens. Do you remember what it was? Because I don't. Let's just move back a little bit. I think it's when you have the same degree, there's no no horizontal asymptote. But let's just make sure here. 94. So I'm going to write this down so all of us can remember it. But basically, if where is it? Where are you? Come on. So and remember, it has to be set to 0. Okay. So for each interval, where are you? Maybe we just don't have to worry about the horizontal asymptotes. So we just need to check each interval. Okay. So the intervals are -3 and +5. Okay. So everything below -3, everything in between -3 and 5, and everything above 5. So let's pick a number below -3. Let's say -5. You guys good with that?
Yeah.
So -5 minus 5 over -5 plus 3. Is that greater than 0? Well, let's see. -10 divided by -2. Negative divided by negative is a positive. So yes. That's true. Now let's try something in between -3 and 5. I'm going to try 0. So 0 minus 5 over 3 is 0 divided by, oh wait, is -5 divided by 3? Is that greater than 0? No. Okay, and then you got, let's try something bigger than 5. Let's try 10. 10 minus 5 over 10 plus 3, 5 over 13. That is greater than 0, yes. Okay, so that means if we plug it back in here, boundary points are just -3 and 5. Boundaries. Number of intervals to test, it's just 3 intervals. Below that, in between that, and after that. Okay, and so x has to be less than -3, or is it equal? And it's just strictly less than. Okay, less than -3, because -3 would make this undefined. Okay, and x, or is a better way. X is greater than +5. So it's got to be greater than, not greater than, or equal to, because 5 will make that 0, which is not greater than 0. So if this is greater than or equal to 0, then it would be greater than or equal to 5. But this is always the case where it cannot be -3. So that's always going to be a strict inequality, either less than or greater than. Okay, so those are your 2 answers. That's it. All right. Good, good? All right, so yeah. So don't worry about the horizontal asymptotes and things like that. You don't have to remember that. But it was a thing. Like, if they're the same, then there's no horizontal asymptote. If the top is bigger than the bottom, then the horizontal asymptote is like 0 or something. And then if it's smaller than the bottom, then it's the leading coefficient ratio, which is weird. So if it was like 3x squared over 2x, then the horizontal asymptote would be y equals 3/2, which is weird. But you don't have to worry about that. That was after our cutoff on concepts that we're learning here. And this is based on tests 94. I thought test 19 just went to 90, but apparently not. So sorry. Okay, number 16, graph this tangent function. Tangent function looks like a cubic function where it just goes like this. It doesn't, there's a sine function, which is like a squiggly, and then a cosine, which is over some, and then a tangent looks like this. Okay, but there's multiple tangents. So you're going to have like this. So you just need to sketch these. So these are tangents. That's what a tangent function looks like. Okay, so 3 pi over 2. That's basically where the vertex is. So it's left 3 pi over 2. So if I drew this, so this is where the vertex is. So -3 pi over 2 is where that is. Okay, so if you just draw that, then that's going to be fine. Because there's no a value, there's no like stretching happening, there's just a horizontal shift of -3 pi over 2. All right, what is happening there? Okay. Okay, that is Not entirely true, I guess. So that's where the cycle ends. Okay, so instead of right here, negative 3 pi over 2, it's going to be right here, negative 3 pi over 2. Okay, we're getting sloppy here, but this is the gist. So you're just shifting that over 3 pi over 2 to the left. Okay, so the period, it's going to say graph that, find the period. So the period, do you guys remember how to calculate the period? So the period is basically how long it takes for this to complete its cycle, okay? Oh, well, that makes sense. It does, yeah, it does shift. It still shifts over there, 3 pi over 2. Yeah. This is the one where I didn't record. Okay, so the period is going to be okay. Yeah, it's just pi over whatever's being multiplied by the x, and there's nothing being multiplied by the x. This is why it's tan of x plus 3 pi over 2. So the period is just pi over 1 because there's no number being multiplied by x. So that's what the period is. So it's just pi. Phase shift of negative 3 halves. So this is a phase shift of negative 3 halves. And the undefined points are basically these asymptotes are undefined points. So it's basically every pi because of the phase shift. So it's every time you get to pi. So this is, so n pi are your undefined. Where n is any integer, positive or negative. Okay, it's painful. All right, number 17. Four more. Okay, we're going to rewrite this as a sum or difference. So this is natural log of 6e over x all to the third. So first thing you can do is bring this 3 out, and it's a 3 times natural log of 6e over x. Well, this natural log of 6e over x, you can turn into a subtraction problem. When you have a division there, so 3 times natural log, why do I keep saying L-I-N? Natural log of 6e minus natural log of x. Okay, well then this one is a multiplication, so you can add those. So this is 3 times natural log of 6 plus natural log of e minus natural log of x. Okay, well natural log of e is just 1 because e to the first power equals e. So then you just have 3 times, you can distribute it out, 3 times natural log of 6 plus 3 minus 3 times natural log of x. That's it. That's all you have to do. So all we did was do the power rule for logarithms, the division, the quotient rule, and the product rule. So power rule says bring it out front and multiply it. Quotient rule says subtract the 2. Power, and then product rule says add the 2. Okay. So that's 17. Let's do 18. Oh, one of these problems again. Let's have the 18 be extra credit as well.
So which one's 18 and 11, was it?
Yeah, 18 and 10, yeah, are extra credit. So half-life isn't terribly complicated, but if you want to look at chapter 93, you can do that, get some extra credit. So we're going to find the excluded values and simplify this expression. So this is 9x squared minus 3x all over 27 times 3x minus 1 all to or squared. Okay, so when you're trying to simplify and find excluded values, the first thing you should do is factor, if anything. So I can factor something out of there. You can take a 3 out of both of those, so you end up with 3 and an x out of both of those, so you end up with a 3x minus 1 all over 27 times 3x minus 1 times another 3x minus 1. Okay, now these would cancel, and this 3 would cancel with the 27, make it 1/9. So then you're just left with your simplified answer would be x over 9 times 3x minus 1. Okay, but before you cancel, you have to consider any excluded values. Well, this is the same thing as that, so the only excluded value is 1/3. Okay? Any questions with that one? This was an older one. Lesson 28. Wow. Okay, determine whether the polynomial blah, blah, blah has a 0 remainder when divided by x minus 3. Okay. So that's easy. We can just use synthetic division. All right. So we just want to know if we get a 0 remainder. Well, you could use synthetic division, or you could plug it in to see if you get 0. You could just plug 3 into that and see if you get 0. Well, let's see. 3 to the 5th is 243 minus 4 times 81, which is 324. And you could do all that out, or you could just use synthetic division. So I'm going to use synthetic division just because I can. Okay, synthetic division. So I'm going to plug in 3, positive 3. So I get 1, -4, -5. Am I missing anything? And then 23, 8, -15. Okay, that's it. So now we just use synthetic division to see if we get 0 here. If we get 0 here, then we can answer yes, it is a root. Okay, so bring down the 1, multiply, 1, 3, -1, -3, -8, -24, -1, -3, 5, 15, 0. Boom. So yes, 3 is a root. And that's all it's going to ask you. It's not going to say factor it, but you could keep going if you wanted to and keep factoring this. The only possible roots are going to be 5 or -5 over here, or 1 or -1. So it's nice you have a prime number. Remember the rational root theorem or whatever it's called. You can figure out which ones are roots by all the factors of this over all the factors of that. So you can keep going if you want, but that's it. That's all it says to do. Let me just make sure we're good. What's Qify? What's determine Qify? That's silly. Q of x. So Q of x would just be this, I guess. It doesn't say what Q of x is, but that's what, I guess when you divide it, that's what Q of x is. So just put, these are your coefficients of your next polynomial. So it's just x to the 4th minus x cubed minus 8x squared minus x plus 5. That's what Q of x is, apparently. All right, that's it.